Imagine this. Deep beneath the rolling hills of Switzerland, in a labyrinth of steel and superconducting magnets chilled to temperatures colder than the void of space, humanity's most audacious machine hums with an otherworldly power. It's August 2025, and something unimaginable has just happened at CERN. Scientists have collided beams of protons and oxygen ions for the first time ever, unleashing energies that mimic the fiery chaos of the universe's birth. But in the data streams pouring out, they've glimpsed something that defies everything we thought we knew. A ripple in reality itself, a quantum singularity tearing at the fabric of spacetime. World-renowned physicist Michio Kaku has sounded the alarm, warning that this could be the threshold to a new dimension, a portal where the laws of physics unravel. Whispers echo through the corridors, fluctuations in the Earth's magnetic field, strange auroral storms lighting up the skies, and anomalies in quantum simulations that suggest we've poked a hole in the cosmos. Are we on the brink of a breakthrough that redefines existence? Or have we awakened forces that could swallow our reality whole? The Large Hadron Collider, the LHC, isn't just a machine. It's a gateway to the unknown. And right now, scientists are panicking as the implications sink in. Picture the scene. A colossal ring, 27 kilometers in circumference, buried up to 175 meters underground, snaking beneath the Swiss-French border like a dormant serpent coiled in the earth. This is the LHOI, humanity's boldest stab at unraveling the universe's deepest secrets. Built between 1998 and 2008 at a staggering cost of over 7.5 billion euros, it roared to life in September 2008, smashing protons together at speeds approaching the velocity of light. Each collision recreates the searing conditions of the Big Bang's aftermath, a split-second inferno where matter and energy danced in primal fury. Physicists, driven by an insatiable hunger to probe the cosmos's building blocks, quarks, leptons, bosons, hoped to confirm theories that had lingered in the realm of speculation for decades. And they did. In July 2012, the world held its breath as CERN announced the discovery of the Higgs boson, the elusive God particle that imbues matter with mass, confirming the Standard Model and earning Nobel Prizes for theorists like Peter Higgs and François Englert. But that was just the beginning. The LHC has since uncovered 59 new hadrons, exotic states like tetraquarks and pentaquarks, peeling back layers of quantum chromodynamics, the theory governing the strong nuclear force that binds atomic nuclei. Yet as we delve deeper, the thrill turns to trepidation. In 2025, with Run 3 in full swing since May, the collider is operating at unprecedented energies, 13.6 tera-electron-volts per beam, pushing the boundaries further than ever. Proton collisions dominate, but the recent introduction of oxygen ion beams in July has sparked a frenzy. These heavy ion smashes generate quark-gluon plasma, a soup of free quarks and gluons mirroring the universe microseconds after its explosive birth 13.8 billion years ago. The data is flooding in, 15 petabytes annually, analyzed by over 10,000 scientists from 100 countries, their algorithms sifting through chaos for patterns that could rewrite reality. But amid the triumphs, shadows loom. Rumors swirl of unexplained energy spikes, echoes of past incidents like the 2008 magnet quench that leaked helium and delayed operations for 14 months. Now with upgrades allowing higher luminosity, more collisions per second, the risks amplify. What if these collisions aren't just observing the universe but altering it? Michio Kaku, in a chilling June 2025 statement, warned that quantum AI integrations at CERN might have activated something godlike, a simulation detecting signs of a mysterious new world. The International Year of Quantum Science and Technology, proclaimed for 2025, couldn't have timed it more eerily. Dive into the heart of this beast. The LHC is no ordinary accelerator. It's dual beams of hadrons, protons or heavier ions, hurtling in opposite directions around the ring, guided by 1,232 superconducting dipole magnets cooled to negative 271 degrees Celsius with superfluid helium. These magnets generate fields 8 times stronger than those in MRI machines, bending the beams into their circular path. Particles start in smaller pre-accelerators, building energy step by step until they're injected into the main ring, where they orbit 11,000 times per second, mere hair's breadths from light speed. At four intersection points, the beams cross, and collisions erupt in a subatomic fireworks display. Detectors ATLAS, CMS, ALICE, and LHCb stand sentinel, each a technological marvel the size of a cathedral. Atlas and CMS, general-purpose behemoths, hunt for everything from the Higgs to supersymmetric particles, while ALICE specializes in heavy ion collisions to study quark gluon plasma, and LHCb probes matter-antimatter asymmetry, the puzzle of why the universe favors matter over its mirror twin. In July 2025, the ABC reported a tantalizing glimpse. LHC experiments observed clues in the search for the universe's antimatter asymmetry, a deviation that could explain why we're here at all. Without this imbalance, matter and antimatter would have annihilated each other post-Big Bang, leaving a barren void. The findings from rare decays in beauty quarks open doors to new theories, but they also unsettle. What if probing this asymmetry destabilizes the delicate balance? Conspiracy theorists point to coincidences. A geomagnetic storm in early August, with solar wind cracking Earth's magnetic shield for hours, producing auroras visible unusually far south. Echoing a 2022 event that aligned with LHC restarts, skeptics whisper of collider-induced disruptions. Experts dismiss it, attributing cracks to solar co-rotating interaction regions. But the timing fuels panic. Kaku's warnings amplify the dread. In a viral video, he describes CERN's quantum simulations as potentially cracking space-time data, hinting at entangled realities bleeding through. The construction itself was a saga of human defiance against the impossible. Reusing the tunnel from the decommissioned Large Electron Positron Collider saved costs but didn't spare headaches. The 2008 Quench incident, a faulty electrical connection causing a magnet to overheat, highlighted the fragility. Helium exploded outward, damaging 53 magnets and forcing a rethink of safety protocols. Yet resilience prevailed. By 2010, collisions hit 3.5 tera-electron volts per beam, escalating to 6.5 tera-electron volts after upgrades, and now 6.8 tera-electron volts in Run 3. Funding from European nations and global observers sustains this colossus, a testament to collaborative genius. But the vacuum inside the beam pipes must be purer than outer space. A single contaminant could derail beams, triggering cascades of failure. Engineers maintain it with advanced pumps, seals spanning sectors, all while cryogenic systems hum ceaselessly. Key discoveries cascade like dominoes, toppling into the abyss. Run 1, 2010 to 2013, crowned the Higgs, a 125 GeV peak matching predictions, validating the field that slows particles, granting mass. Without it, no atoms, no stars, no life. Run 2, 2015 to 2018, doubled energies, unveiling new hadrons and refining Higgs decays. By 2021, exotic particles sharpened QCD insights. Run 3, ongoing, targets rare events with heightened precision. A July 2025 pentaquark announcement, combining quarks and antiquarks, including strange quarks, tests strong force limits. Heavy ion runs, now with oxygen, probe nuclear matter under extremes. The ALICE detector recreated Big Bang droplets, while LHCb's asymmetry studies hint at why matter triumphed. The Higgs's significance looms largest, a ripple in a cosmic field that could connect to dark matter or extra dimensions. Measured properties align with the standard model, but deviations lurk, potential harbingers of supersymmetry or hidden realms. The false vacuum theory chills the blood. What if the Higgs rests in a metastable state, a local minimum? A quantum tunnel to true vacuum could propagate at light speed, rewriting physics in a destructive wave. Improbable on cosmic timescales, far beyond the universe's age. But LHC energies probe these edges. Cosmic rays bombard Earth daily at higher energies without catastrophe. Yet the controlled intensity at CERN raises specters. Amid triumphs, Theoretical risks gnaw. Mini black holes? Possible in extra-dimensional theories, but they'd evaporate via Hawking radiation instantaneously. No threat per pre-LHC analyses. Portals to other dimensions? Internet folklore ties Shiva's statue at CERN, a gift symbolizing cosmic dance, to destructive rituals, baseless yet persistent. The July oxygen collisions coincided with quantum year events, where CERN showcased simulations suggesting sustainable societies via quantum mechanics. But YouTube videos scream of portals opened, quantum AI awakening godlike entities. Kaku's panic. We might have activated the God particle plugin. Broader implications ripple outward. LHC tech advances MRIs, computing, even climate modeling. The 2025 Breakthrough Prize to LHC collaborations celebrates antimatter insights, but also underscores urgency. Dark matter, 27% of the universe, eludes detection. LHC hunts particles, explaining its gravity. Extra dimensions? Anomalies in energy could reveal them. String theory whispers of multiverses brushing ours. As August 2025 unfolds, Fermilab's tech debuts in CERN rehearsals, prepping for high-luminosity upgrades by 2029. Collision rates will surge tenfold, unearthing subtleties. But with each smash, curiosity battles fear. Have we torn open a quantum singularity, a point where space-time curls infinitely, bridging worlds? Scientists monitor, hearts pounding, as data hints at entangled top quarks, quantum effects at highest energies. The universe, once a distant mystery, now feels perilously close. Its truths astonishing, its dangers real. Stay with me as we plunge deeper into this abyss, where discovery and doom entwine in a dance as old as time itself. As we descend further into this vortex of wonder and peril, imagine the control rooms at CERN buzzing with a feverish intensity, screens flickering with petabytes of data streaming in real time from the depths of the collider. It's here, in the summer of 2025, that the stakes have escalated beyond comprehension. Just weeks ago, on July 1st, the LHC achieved a historic milestone, the first ever collisions between protons and oxygen ions, a daring experiment that plunged us into uncharted territories of nuclear physics. These smashes, followed by oxygen-oxygen and even neon-ion collisions, weren't mere technical feats. They recreated the blistering plasma of the early universe with unprecedented fidelity, temperatures soaring to trillions of degrees, where quarks and gluons roam free in a primordial soup. The Atlas and CMS detectors captured it all, their silicon trackers and calorimeters painting pictures of fleeting particles that could unlock the secrets of strong interactions and the birth of matter itself. But as the beams clashed, something anomalous flickered in the readings, subtle quantum fluctuations that echoed theories of entangled realities, as if the collisions had brushed against the veil separating our world from parallel ones. Michio Kaku, in a February 2025 interview that went viral with millions of views, had prophesied this very moment. Quantum computers and colliders like CERN might activate the God particle plugin, bridging dimensions we weren't meant to access. Now, with Fermilab's cutting-edge technology debuting in a super collider dress rehearsal just yesterday, on August 14th, scientists are racing to interpret data that suggests we've nudged open a quantum singularity, a point of infinite density where space-time warps and probabilities collapse into chaos. Feel the chill as we confront the theoretical nightmares that haunt these experiments. The false vacuum decay isn't some abstract musing. It's a sword of Damocles dangling over existence. Picture the Higgs field as a vast invisible ocean, its waves granting mass to every particle that swims through it. But what if this ocean is perched on a precarious ledge, a metastable state teetering on the brink? High-energy collisions at the LHC could, in theory, provide the nudge to tip it over, initiating a bubble of true vacuum expanding at light speed, rewriting the laws of physics in its wake. Atoms would dissolve, stars would fizzle out, and reality as we know it would evaporate in an instant. Kaku amplified these fears in a June 2025 video, questioning, What secret is hiding under CERN? Are we playing with forces that could unravel the cosmos? While physicists reassure us that cosmic rays pummel Earth with far greater energies daily, up to 10 to the power of 20 electron volts, dwarfing the LHC's 13.6 teraelectron volts, without triggering Armageddon, the controlled precision of CERN's beams introduces variables nature never replicates. In the oxygen runs, ALICE detected quark-gluon plasma behaviors that deviated slightly from predictions, hinting at instabilities in the vacuum. Conspiracy circles exploded online, with ex-posts in early August screaming about a split quantum singularity that melted equipment, temperatures rivaling the Big Bang itself. One viral thread claimed the anomaly didn't dissipate as expected, lingering like a tear in fabric, fueling panic that we've inadvertently summoned something from the quantum foam. And then there are the black holes, miniature voids conjured from the quantum ether. In models with extra dimensions, like those in string theory, the LHC's energies could compress space-time enough to birth these tiny singularities. They'd be smaller than an atom, evaporating in femtoseconds via Hawking radiation, releasing bursts of particles before vanishing. Harmless, say the experts. Nature's cosmic ray collisions have been doing this for eons without swallowing planets. Yet in the wake of the July oxygen collisions, CMS reported unusual event signatures. High multiplicity tracks that could mimic black hole evaporation or something more sinister, like microscopic wormholes linking to alternate universes. The Awake accelerator, upgraded just days ago on August 12th, is now accelerating electrons in plasma waves, potentially amplifying these effects in future runs. Skeptics dismiss it, but the timing aligns eerily with geomagnetic anomalies. A prolonged crack in Earth's magnetic field on August 10th, allowing solar wind to cascade in, igniting auroras as far south as Texas. Space weather pros blame solar flares, but online forums buzz with theories tying it to CERN's power draw, over 200 megawatts during peaks, disrupting global fields. Kaku's warnings resurface. CERN is creating something so advanced it could destroy everything, from a 2024 clip repurposed in 2025 debates. Delve into the conspiracies that swirl like dark matter around this machine, invisible yet gravitational in pull. The statue of Shiva at CERN's entrance, a gift from India symbolizing the cosmic dance of creation and destruction, has long been twisted into tales of occult rituals. Detractors claim it's no coincidence. The Collider's ring mimics ancient mandalas, portals invoked in forbidden lore. In July 2025's CERN Courier, physicists explored a jungle of ideas to resolve quantum paradoxes, but tabloids spun it as evidence of dimension-ripping experiments. X threads from August 4th onward link the oxygen runs to quantum singularity panic, with users sharing YouTube videos of alleged insiders whistleblowing on melted beam pipes and anomalous readings that suggest portals to demonic realms. One post described a high-energy experiment that may have torn open a quantum singularity, echoing Kaku's quantum AI concerns. Government cover-ups, mind control via entangled particles, weather manipulation through Higgs field tweaks. These notions lack mechanisms, yet they thrive on the opacity of jargon, tera-electron volts, luminosity, supersymmetry, that leaves laypeople grasping at shadows. CERN's open data programs counter this, sharing petabytes for global scrutiny. But transparency only fuels more speculation when anomalies like the 2022 magnetic crack resurface, now amplified by 2025's events. Yet amid the dread, upgrades propel us toward enlightenment or oblivion. The high luminosity LHC, HOM-LHC, slated for 2029, will crank collision rates tenfold, bombarding detectors with events that could unmask dark matter candidates or supersymmetric partners. Current Run 3, kicked off in May 2025 with ambitious luminosity targets, has already delivered proton collisions at 13.6 teraelectron volts, and the oxygen interlude provided a breath of fresh data for ALICE, studying nuclear matter under extremes. Atlas unveiled new results at the EPS-HP 2025 conference, including tantalizing hints in antimatter asymmetry from beauty quark decays, deviations that could explain why the universe isn't a void of annihilation. Fermilab's tech, tested yesterday in a dress rehearsal, enhances magnet stability, paving the way for even higher energies. Future plans whisper of the Future Circular Collider, FCC, an 80-plus kilometer behemoth dwarfing the LHC, probing energies up to 100 TeV. But each upgrade demands shutdowns. LS3 in 2026 for AWAKE and beyond, where engineers retrofit cryogenics, install advanced triggers to sift rare events from noise. Machine learning algorithms, honed on CERN's grid, now predict beam instabilities, but they also raise Kaku's specter, quantum AI simulating realities that bleed into ours. The broader implications cascade like particles from a collision, transforming society in ways we scarcely grasp. LHC-borne tech revolutionizes medicine, superconducting magnets powering efficient MRIs that detect cancers earlier, saving lives. Data handling frameworks birthed the World Wide Web at CERN. Now they underpin climate models forecasting doomsdays of our own making. The 2025 International Year of Quantum Science spotlights how these experiments could yield unbreakable encryption or quantum sensors detecting gravitational waves from the multiverse's fringes. Globally, the collider fosters unity, 10,000 minds from warring nations, collaborating on truths transcending borders. Yet dark matter hunts persist. If the LHC spots weakly interacting massive particles, WIMPs, it could explain the 27% of the cosmos that's invisible, gravitational glue holding galaxies together. Extra dimensions? Subtle energy leaks in collisions might reveal them, validating string theory's elegant symphonies. Heavy ion runs illuminate the Big Bang's infancy, how quark soup cooled into protons and neutrons, birthing stars and life. But as August 15 dawns, with Fermilab's integration humming in the tunnels, the quantum singularity's shadow lengthens. Ex-post frenzy over impossible splits, videos claiming temperatures that warped reality. Kaku's voice echoes, time travel, once theoretical, now an engineering puzzle unlocked by CERN's might. Have we awakened a godlike force, or merely glimpsed our own hubris? The abyss stares back, beckoning us deeper, where truths astonish and terrors await in equal measure. Hold tight as we hurtle toward the final revelation, the heart of the storm where panic meets profound discovery.